Hello everyone, welcome to the SQRT channel. In this video, we are going to talk about a problem that we got from Hong Kong Maths Olympiad from 2020. In this problem, we have a right triangle as DBC and the angle that we have for B is the right angle here. AC and BF are making a right angle at E. We know that the angle that we have for BAC is equal to the angle that we have for DAF, and we also know that AB is equal to 1 and BC is equal to 3. Based on this, we want to find the value that we have for AD. Before moving forward to talk about the solution, make sure that you pause the video to think about the problem. To solve this problem, we are going to start with showing that the angle that we have for EBC, or the purple angle here, is going to be theta as well. In the triangle ABC, we have a right triangle B, and we have C and then the theta. Now consider the triangle here that we have for BEC. Here we have a right angle at E, C is common between the two triangles, and we can conclude that the purple angle that we have here is also theta. Now let's move forward and consider the two triangles that we have here. One of them is green and the other one is orange. These two triangles have the same height, and we can say that the area of the green triangle is going to be the height times df. On the other hand, the area of the triangle that we have here in orange is going to be the height times cf. Since height is common between these two triangles, the ratio between their areas is going to be the ratio between their bases, or we can say the ratio between the area of BDF and BCF is going to be the ratio between DF and CF. Now consider the two triangles that we have here. One of them is green and the other one is yellow. You can verify that these two triangles have a common height. So DF over FC is going to be the ratio between the area that we have for ADF and the area that we have for ACF. Now we are going to write the area that we have for BDF as 1 over 2 times BD times DF times sine of 90 degrees minus theta. For BCF, we are going to write it as 1 over 2 BC times DF times sine of theta. We can use the same approach, and for ADF, we can write it as 1 over 2 AD times AF times sine of theta. For ACF, we will use 1 over 2 times AC times AF times sine of 180 degrees minus 2 times theta. Then we will use cosine of theta as sine of 90 minus theta, and we will use sine of 2 theta as sine of 180 degrees minus 2 theta. At the end, we will have BD cosine of theta over BC sine of theta is equal to AD sine of theta over AC sine of 2 theta. Now we are going to use 2 times sine of theta cosine of theta as sine of 2 theta. Then we will remove the common terms again, and then we will end up with now here we are going to simplify it a little bit further. We do this by writing 2 times AC times BD times cosine squared of theta is equal to AD times BC times sine of theta. Now let's find out the values that we have for cosine of theta and sine of theta. In the triangle that we have here as ABC, AB is equal to 1 and BC is equal to 3. Then AC is going to be SQRT root of 3 to the power of 2 plus 1 to the power of 2. So AC is equal to SQRT root of 10. Then sine of theta is going to be 3 over SQRT root of 10. And cosine of theta is going to be 1 over SQRT root of 10. Now we have sine of theta and cosine of theta. Let's replace these values in the equation that we have here. We have 2 times AC, and we know that AC is equal to SQRT root of 10. We have BD, which is equal to 1 plus x, and we have cosine squared of theta. We saw that cosine of theta is equal to 1 over SQRT root of 10. On the other side we have AD, that's x. We have BC, which is 3, and we have sine of theta, which is 3 over SQRT root of 10. At the end we have 2 times SQRT root of 10 times 1 plus x times 1 over 10 is equal to 3 times x times 3 over SQRT root of 10. If you simplify it, you can verify that x is equal to 2 over 7 is the answer.